video. On this channel we are going to be focusing on and explaining STEM topics, specifically those related to electrical engineering. So if you're an aspiring EE student, school hobbyist, or just someone who's interested and want to learn more about the school stuff, definitely watch and subscribe. Now with the intro out of the way, let's get started with learning simple circuit concepts, analysis, and components. So first thing we're going to start off with is voltage and current. So what is voltage? If you remember from your physics class, voltage, which is the electric potential, is pretty much V equal to the change in energy over the change in charge, and that's measured in joules per coulomb. Coulomb being like the charge, measurements in charge. And right in electrical circuits, you're either going to see them in diagrams. You're going to see them like this, where it's a circle with the plus and minus, and you have the value of that voltage source. In digital systems, you might see them as this. It's like a capital T with the node, and then later on in your circuit, you'll see the ground, which is either this, it's going to a triangle, or you might see it as as going into a line, and then all these little lines popping out of it. And sometimes it depicts a battery, which you have the plus and the minus, and then you have like these cool lines going here. And so the rules for voltage sources when hooking them up is these have to be the same. So these have to be the same polarity, and they have to be the same value. So you have plus and minus hooked up to plus and minus. They're both equal 10 volts. And this is just proof of Kirchhoff's voltage law, saying that in a loop, which is how these guys are connected, they're connected in one loop. You have 0 has to equal the sum of all the voltages. We have V1 plus V2 plus V3, all the way going to Vn. So like if we prove this, it would be 10 volts plus minus 10 volts. See, because it's fighting, this 10 volts is fighting against this 10 volts, and they're eventually going to cancel each other out to make it 0. Okay, so for current, which we measure in amperes, current is going to equal the change in charge over the change in time. So we have coulombs per second. And in a circuit diagram, you're probably going to see current sources being, it kind of looks like a voltage source, except instead of the plus and minus, we have the arrow going here. And we have the value of the current that's going in. Now, for these to be connected, they have to be the same value connected in series. And they have to have this, they have to be the same value, and they have to have the same direction flowing. Okay, so if I had a 3 amp voltage source going in here, 3 amps, this wouldn't be true. This just doesn't make any sense. Like, how can you have that? How can you have 5 amps just flowing through and then all of a sudden change to 3 amps? Okay. And that leads us to Kirchhoff's current law. You see how when we have, let's say we have a current source going in, it's going to, if we have multiple, let's say a current source goes into a node, and it's splitting off into like different parts of the circuit. It's going to split up evenly so that all these currents add up to this current source. So we have I1 plus I2 plus I3 all the way to IN has to equal 0 at a node being this little black dot right here. So in some of your classes, you won't just be dealing with independent sources, you're also going to be working with dependent sources. And dependent sources, let's just start with the voltage. So you see, for independent sources, it was it was a circle plus or minus. For independent sources plus or minus circle, and then the value that stays whatever it is. And then dependent sources, we have, it looks like a diamond. We have the plus or minus, and then we have our voltage, which has a variable in it, this variable being the alpha here. And if you were said to solve what would be the value of alpha, just to make the circuit true. You remember back when we said that they had to have the same polarity, and they have to have the same value. So it's hooked up plus or minus, and we have 5 volts over here on our dependent source. So our alpha has to equal 5 in order for the circuit to be viable. And if we look at the current sources, it's pretty much the same way. It transformed it back to a diamond. We have an arrow, we have our amperage, and our variable for the amperage. And if we were given a circuit, 5 amps, to make this true, beta would have to equal 5 amps, going in this direction. Now, let's say you calculated it, and actually no, not even calculated. Let's say instead of that, it was like this. The polarity was switched, and they still give you alpha V. Then you would just make it negative 5 volts. Right? Because it was plus 5 volts, voltage is going to go this way. But when you have negative 5 volts, these polarities get switched. So now it's going the true direction where it should be going. And last thing we're going to go over is power, which is we measure in watts. And power is going to be the change in energy over change in time. Now, how do we get that? Power is equal to voltage times the current. So if we remember what our equations we get, we have voltage times current, which is voltage being the change in energy over the change in charge, and our current equaling to the change in charge over change in time. These will cancel out. These change in charge are going to cancel out. We get the change in energy equals the change in time. I don't know why my W looks like that. There we go. And this is calculating the power generated and dissipated is going to be useful to you once we get farther in circuit analysis, because it's going to make sure that we have like all of our numbers correct. So let's say we have a voltage source here, or it could be a current source or anything like that, and we have components X, Y, Z. So power generated would be the power generated by the source, this case being the voltage source. And the power absorbed is going to be the power absorbed by the components PX, PZ, PY. And then, so we know that power of the voltage source has to equal the power of absorbed by the components, which will have to equal 0. And we call this a power balance equation. And it kind of helps prove your work. So that was the video. Subscribe and come for more.